Well, hi and welcome to my shop. Thanks for joining me here. I've just finished replacing all the capacitors in the audio circuits of this A23 RCA Victor A23 Canadian made radio. And I have all the capacitors I took out. What I want to do is test all the capacitors I removed to see what condition they were in, and then test the radio and see if there's been any improvement in the audio section, especially this I don't know what to make of it. This thing I noticed during the testing in the last video, where as you raise the input signal level, the speaker seems to remain at the same volume and then suddenly becomes louder. So I'm not sure what that's all about. Bad capacitors, don't see how that could be the case, but then again, it's not like I haven't been surprised before. So, okay, well, we're going to start with testing all these capacitors. See them all here. There's 7 of them. We'll start with the most likely to be good. These, pretty sure they're mica inside here. And one of these had a big crack in it. Not this one. This is a 180 picofarad capacitor, pretty small. So the test I'm doing here is applying voltage across the capacitor, and then the leakage current. Whoops! The leakage current will affect what this eye is showing here. Now, let's just make sure all this is good. Yeah, good. You can see that, especially if I put a little shadow on it. Perfect. Okay, we're all set to go. So first voltage is going to be 50 volts. The eye will close during the charge, which will be very, very quick in such a small capacitor. And it should pop open just like you see it now if the capacitor's leakage is very low. There we go. Look at that. So there's no leakage in this capacitor. That's 250 volts across it. So because there's no leakage, I can make a fairly accurate test of its capacity. And I'm not going to be surprised to find out it's normal. Let's take a look here and see. I think this is the 180 picofarad. I think that 180 picofarads. Wow, I don't know. That's a pretty small one. Be here somewhere. Okay, so what we do now is we swing this control and watch for the eye to open. So it opens quite clearly right here. The scale I'm on is the inside scale. We come around. So that's 0.0001 and that's 0.0002 here. So it's between 0.0001, might be like 0.00015. That would be the same as 150 picofarads by my, and it's a 180. So it's a 180 reading 150 on here. That's interesting. Now here's the next one. This one I'm sure has a crack in it, in the shell, right through here. Again, I suspect this is going to be just fine. We'll start by testing it for leakage. Okay, here we go. Yeah, look at that. You didn't even see it close. It's such a small capacitor. Right? 250 volts, no problem whatsoever. So these two capacitors I probably could have left in. No detriment to the radio at all. But there's only one way to really find out, and that's to remove it and do this kind of thing. So this is a 220. 220 would be just up here somewhere. Look at that. So, you know, my experience with these guys is really good. And maybe I should have more faith in them from now on. But again, the only way you know for sure is to remove it from the circuit. Or at least open one leg of it. Once you've cut one leg, well, you've got it half replaced. You might as well put a new one in at that point. So it's either leave them totally alone, or cut them out and... Okay, fine. Now let's get to the ones that are pretty certain to be bad. We'll start with this one. This one, you know, look at the rest. This one is new. It was quite clearly this was installed by somebody making some kind of repair. This is the capacitor that carried the audio signal from the volume control on towards the preamp. So all the sound goes through here. So let's check it out. So first we'll check again to see if it's leaky. Looks to be in really good shape actually, so again this one might actually be in pretty good condition. Okay, 50 volts, what do? That's pretty good. Lots of these old capacitors, you'll see it with these. The eye won't open even on 50 volts. Looks good, 250. So this replaced capacitor is still in pretty good shape, and good enough that we can check its value on here too. This is a 0.004. 0.004 would be on this scale here, right up towards the end, I think. Here we go. There it is there. And if we look on the scale, it's 0.005 on here. And this is a 0.004. So again, this capacitor probably could have been left in. Now let's hope and pray. Hope and pray. Some of these are really bad. Or else I will have wasted some time here. Exactly what each of these capacitors was doing, I didn't bother making a note of it. I know what one of them was doing, but the others I'm not exactly sure. Okay, are you leaky? 50 volts. Watch the eye. Well, it came open. Let's try 150. There you go. So you see the eye is failing to open at 150. Opening a little bit. There's no reason to try to test this capacitance, because once it's leaky, most testers can't test a leaky capacitor properly. A leaky capacitor, it appears to have a resistor in parallel with it. And the instruments are not designed for that situation. Most are not. Okay, right on the next one. 50 volts. Okay, it opened. 150. It doesn't open at all at that point. So that is staying closed because there's a leak through the capacitor. So it's no surprise these ones are shot. These could affect the performance of the radio significantly depending upon exactly what they're doing in there. This radio is unresponsive on shortwave, or minimally responsive on shortwave. Okay, here we go. 50 volts. There, 50 volts. Looks just like the last one, 150. Opens a bit. What about 250? No, not going to open at 250. So these are certainly showing their age. Like if one of these is the grid blocking capacitor, it's blocking the plate voltage from the previous stage, then a little leak like that, very significant. Other places, not so much. This capacitor is the one that if you hooked up a record player, the record player signal would come through to get to the amplifier. So again, not very important. But this capacitor will have been sitting, doing nothing in this radio the whole time. Just sitting in there. Might as well have been on a shelf somewhere. Let's see what happens to it on the shelf. Well, not so good. Yeah, that's actually the worst one so far. The capacitor that did nothing. That's it. I've done them all. So just taking a look at them here. Again. Okay. One of these capacitors does not belong here. Which one is it? It's this one. That's right. These all tested bad. This tested okay. These two tested actually very good. There we are. Now we're going to find out about the radio itself. Find out how it's fared during this process. Now, normally I do not shotgun capacitors. I don't normally change a lot of capacitors without testing the radio. In fact, often I'm doing one at a time and testing the radio after every capacitor. But not this time. I did all 7 audio capacitors in here. And we'll find out now if I made a boo-boo. Okay, we're going to set it down. There. Okay. Now you can get a good look at the warp in the speaker here with the way the lighting is. You can actually see warping in here. See a little around here. So I'm taking a wild guess that the reason this radio seemed to not produce volume until the volume control was high enough, it seemed to break through something, that maybe the speaker is stuck in place. Sure doesn't feel like it. Feels perfect. It feels perfect. So my guess is probably worth nothing. So we're going to plug it in over here. Switch is off. Okay, we're on the dim bulbs. Ready to go. Now, of course, I've made lots of changes. So if I mess something up, these lights are going to come on full tilt, and I'm going to run for the hills. You ready? In fact, rather than hold on to this control, I think maybe I'll apply the power with the switch up here. Ready? Here we go. Golden. I think it's good. I think we're good. Okay. Volume. It's a pretty good sign. We're on the AM band. You hear that distortion? There's a good chance that's the speaker. Let's put full power on the radio. There's a good chance the speaker is shot on this radio. Let's try again. So what I'm hearing in there is a bit of a rattly sound. A very kind of comes along with of course, the louder, lower tones in the person's voice. Let me turn it up a little higher here. Well, that's clearly a large amount of serious distortion. It's not so likely to be coming from the radio circuits. And it's not so likely to be coming from the audio circuits anymore. It's most likely the speaker itself sounds like that. That is too bad for now. Maybe not. Maybe that's not the state of affairs. What I'm going to do is I'm going to try that thing again where we feed an audio signal straight into the phono input. And we'll see what the speaker sounds like with a more controlled tone. But not feeling so good here. It's really kind of one of the things you don't want to have. You don't want to have a defective power transformer. You don't want to have a defective speaker. Just about everything else can be dealt with. Coils are a problem too. So you say coils, power supply transformer, speaker, those are the killers, let's put it that way. I hate to say that, but okay, this is never going to be, Mr. High Fidelity, but that rattly distortion is very, very annoying. So I flipped it over so I can insert the signal onto here. That's why I've done that. Let me just block it up here a little bit. I have tried other systems of support for radios I'm working on, other than putting in piles of blocks of wood, and never really had a satisfactory result of that. That's why I continue to use blocks of wood here, for those who might be interested in that. Okay, now we're going to be listening to this. I'm not going to bother analyzing it with any equipment just yet. I think our ear is the #1 analyzer for this kind of thing. So we're going to put on the power. Oh, I need to get the input signal ready. Little input signal. And we can actually put on a power. 2. Now, because I put the new capacitor here, I don't have to worry about a charge being coming out of the radio and going into my signal generator here, which seems to have suffered some kind of failure anyway. My sweep generator has a series, you can see them here, a series of buttons here that control the speed of the sweep. You know, that's a 10-second sweep. That's a 1-second sweep. Well, guess what? When you push 1 second, it takes 10 seconds now. When you push 10 milliseconds, it takes 1 second. So something's happened in my gizmo there. But I don't think we're going to be sweeping it. Okay, where are we at? Yeah, let's try this tone control. I discovered that, in fact, there's a tone control here. I thought this was to select between the audio input and the radio, which makes a lot more sense to me. It's a tone control. Let's flip it. Pretty strong tone control. Now you can even hear the distortion better now. Wow, you know what? I give it 90%, that's the speaker. Let's experiment here. Okay, there's no question. The speaker is in big trouble in this radio. There's no question about it. So I'm going to attempt the first type of repair on this kind of problem. I've done this once before. It worked. I was a little stunned. Sounds to me like the last thing on earth you want to do, and that's just soak the cone in water and leave it sitting. Not like that. Leave it sitting perfectly upright. So I have to figure out how to prop this radio up on its back. Actually, it doesn't look too tough. It doesn't look tough at all. Let's put it on its back here. Oop, oop, pull it out. Oop, shut off. Okay, pull it out now. Okay, so chances of fixing the speaker, from my experience, and I don't have a lot of experience, just doing simple things like what I'm about to try, I just don't think is very likely to be successful. Well, let's see what happened here. But, and in terms of making it worse, it can't get much worse, frankly. It really can't get much worse. Let's go up in the world here. Back down here. Now, let's say I've done this once before. You soak the cone and you just leave it. And the theory is it will settle itself back in. Otherwise, my options here are replace the speaker entirely. That's tricky. You pretty much need another one of these radios to get exactly the right speaker, dimensions, drill holes, all that kind of stuff. Proper output transformer. You got to get the same speaker. You can get away with fudging it a little bit, but so really, it's really important to try to get this guy working better anyway. Well, I'm going to soak that. I really haven't got a better idea here. Okay, so what I'm going to do here seems like a crazy idea to me. But it's worked once in the past for me. I've actually taken a speaker pretty much like this, done what I'm about to do, and it has straightened it out. So I can't leave the speaker the way it is. This radio just sounds terrible. Yes, this is what I'm doing, soaking it with water. This is kind of like, well, how do you think it got warped in the first place, Jim? Soaked somehow. Notice the position of the radio. I have it sitting so the cone will settle down. I guess maybe literally the weight of the cone, of the voice coil, which can't be very much, is what's going to pull this back into the center. Wow. Do you really believe that? I don't know. But the thing is, you know, unless I do something, this speaker's shot. I'm not about to try reconing it. My next alternative, if this doesn't help out, is going to be to find another speaker, stick it in the back of the radio, hide it in the back of the radio, and disable this one. I think that's my suggestion. So warp is still sitting right there. It's very soft now. Well, it's very flexible. No doubt about it. Yeah, wow. If I push hard, I'm going to go right through this. Okay, we're going to leave it just like that. That's it for today. We'll find out what the heck I've done when we listen to this tomorrow.